My name is Vesna Manojlović, and I'm a dinosaur. I'm a little bit younger than the internet, so the internet is quite old. And the people that created the internet are quite old, and IPv6 is also old, so this is why I'm talking about the dinosaurs today. Another reason why, my talk is about inviting you to take part in creating the future of the internet. And the best way to invite this crowd to take part in anything is to tell them that it's forbidden. So please keep out. This is the dinosaur area. If you were here to listen to Marco's talk, then he mentioned that they have several paying customers that have native IPv6, and I'm one of them. This here is my prefix, so I have IPv6 at home, and I wanted to talk about that on this conference and to talk about the user experience and how is that to get IPv6 and how is that to have it at home. But actually there isn't much to talk about because they gave me the modem, I plugged it in, I turned it on, and then everything just works. So if you want to hear that kind of talk, then this is the end. You can go enjoy the sun. And if you want to hear a little bit more about the background of the IPv6 and also about the future of the internet, then I will be talking about that in a function of self-proclaimed IPv6 ambassador. I work for RIPE NCC as a trainer, but I'm on vacation now, so I'm not actually representing my company, although I find it a bit difficult to separate the work and pleasure, so I actually like talking about IPv6. I do that for work and I do that on vacation. So I'll be just talking to you about how we are running out of IPv4 addresses, why should you go to IPv6, and I hope that in the end I'm going to persuade you that you can take part in creating standards and you can take part in creating the rules and the policies for distribution of IPv6 and IPv4 as long as we still have it. So I have this /48 prefix at home. I will be talking about it, what does it mean? And I also have so I have IPv6 and I have IPv4, and I don't actually know what is happening when I try to reach some website, which one is like if I'm reaching it over IPv4 or IPv6, and actually I don't care. And I know that end users don't care about this and they shouldn't care. So in my world, it just works. The only difference is that now I have this prefix, and in IPv4 I have one IP address. So if I have more than one computer behind that address, then I have to use private addressing and I have to use translation. Network address translation. So the point here is that the size does matter. So the main advantage of IPv6 is that there is more of it. We have outgrown the IPv4 internet. As Marco said, the internet is full, and we actually don't want to tell to people, oh, go away because you cannot talk to us anymore. We want to invite more people to join our internet, and the only way is for them to go to IPv6 because it is supposed to be larger than life. It is supposed to last until the eternity, and of course that's what they thought about IPv4. So however large the address space of IPv6 is, it is not going to last forever, and it is going to be replaced by something better. And I want you to take part in creating that something better, which no one actually knows what it is going to be, but it will happen. So usually we see a lot of graphs and diagrams and pie charts, like so many IPv4 addresses are gone here and so many are gone there, but it doesn't matter because sooner or later we are going to run out. On the other hand, it's not going to be a crisis. It's not going to be one day, which is a doomsday, and now there is no more IPv4 addresses available, because they are used and distributed in the hierarchical way. So one day, IANA will run out. IANA is the Internet Assigned Numbers Authority. It's an organization that is distributing all the numbers in the world, IPv4 addresses, IPv6 addresses, AS numbers, and all kinds of protocol numbers. They give IPv4 addresses to regional internet registries. So at the moment when IANA runs out, the regional internet registries will still have addresses for another 6 months, year, 3 months, who knows. So there will be one day when IANA runs out. There will be another day when each one, or well, there will be 5 days when each one of the 5 RIRs runs out. But at that moment, we will still have IPv4 addresses because local internet registries, they also received in the past, and they will receive from the regional registries, big blocks of addresses that they are using to give to their customers. So in the future doomsdays, when we are running out of IPv4, at some point the end user will go to the ISP and say, can I connect? And they will say, sorry, we are run out. But it doesn't mean that it will happen on the 13th of April, a certain year. It will happen in different parts of the world at a different stage, but it will happen. So how does that now reflect to the IPv6? Well, IPv6 is also distributed in a hierarchical way. And we have learned some lessons, and one of the lessons is we actually don't know how to distribute such a scarce resource. So we made a lot of mistakes with IPv4, and we thought, okay, let's not make the same mistakes in IPv6, but we are making other mistakes. So to prevent ourselves from messing up big time, IANA is right now distributing address space from only 1/8 of the available IPv6 space. And if we make a total mess, if we waste the address space, if we make a lot of mistakes, never mind, in the future we will get another 6 or 7 chances. So from this huge block, they give other big blocks to the regional registries. Regional registries give the minimum size of /32 to local registries. It's possible to get much larger blocks. And in IPv6, it was planned that there will be more levels of hierarchy than in IPv4. So the big providers are supposed to give parts of their space to the smaller providers, and then the smaller providers are supposed to give part of their space to the end user. However, this was all planned more than 10 years ago, so the design of IPv6 was not really adjusted to the current business situation of the internet, where everyone wants to be multi-homed. So that is still a problem, and it's not really solved in IPv6. There are several solutions being played, being standardized in IETF. I will talk about that. But this is the current model. So if you are a customer, you can get a block of /48, like I have at home, or smaller blocks. Or if you want to be independent, if you don't want to get your space from a provider, you can get provider-independent addresses directly from the regional registry. In Europe, that is RIPE NCC, which is situated in Amsterdam. So there you go. If you're a small company, you can get your addresses that way. Okay, how many of you actually know this? How many of you know all of this about addressing, basics, prefixes, bit sizes? Okay, most of you. So I'll just mention few controversies, because that makes it a bit more lively. Oh yeah, I didn't mention, but if you have any questions at any time, don't wait until the end. Just look for the microphone and then shout your question. So the design of IPv6 address is, well, it is going backwards a little bit, in a sense that the address space is supposed to be given in the fixed size chunks. So we are going away from the idea of host, and we are going to the idea of the subnet of /64. So every subnet will have huge amount of space. So you will be able to put a lot of devices in one subnet. And some people find that very wasteful. Like, why should we do this? How many devices can we put in a subnet? Which devices? But on the other hand, this was planned for the future and for the unexpected growth and the unexpected devices that will need addressing. So maybe today we don't know what we are going to number, but in the future there is a possibility to do that. Okay, so the other controversy is that the end user at home receives quite a large block, /48. This gives me 16 bits to create 65,000 subnets. So once the equipment can actually do that, I can have 65,000 subnets at home. Why do I need them for? This is also wasteful. Some ISPs say, no, I'm not going to give to my customer /48. What are they going to do with it? Well, it doesn't matter. They will never come back to ask for more. So that makes it easier for the ISP. They deal with the customer once, and they never have to see them again. And then in the future, maybe there will be something that I will do with all those subnets at my home. On the other hand, the ISPs have only /32, so they can have 65,000 customers like me. So this is not going to scale. If the ISP has more than so many customers, they will have to ask for more than /32 of IPv6 space. And that's possible. That is how it is. But these rules of how many bits to give to whom and what are they going to do with that, these rules are called policies, addressing policies. They are developed in the RIPE community, and you are the part of the RIPE community. So you could change these rules, and they keep on changing, and I'll show you later how to take part.
Are the rules the same in the other regions, like Aryan or APD?
So the question is, are these rules, these policies the same in other regions? They are not. So these rules are created in a grassroots way in the local environment to be suitable for that certain community and that certain environment. So let's say that in Europe we have large companies and large ISPs that need a lot of addresses. Maybe in African region they don't need so many, so then they will have different policies. Also the rules, how can you justify to get addresses, are different in different regions.
If you get a portable /48, are all the providers required to put it in the routing table so that you can to be their customer?
So the question was, if you receive portable addresses, the provider independent, oops, no, I did something, I'm sorry. So I'll just answer the question, I'll go back to this later. So the question was, if you get portable addresses, are all the providers in the world going to carry that prefix in their routing table? Theoretically, yes. Practically, it depends on the provider. The policies about the addressing are not strictly related to the routing. So there is an attempt to make it possible for these prefixes to be not filtered out by other providers. Regional registries are allocating these longer prefixes, these smaller blocks, from a separate block, and we document that. So we say, if you want to carry these prefixes, they will be coming from a certain block. And some providers base their routing and filtering policies on that, and some others on their other business decisions. So Marco was saying that it is the same in IPv4. Yeah? So the idea is that if you get such a block of /32, you should announce that as one prefix. You shouldn't deaggregate. And these bigger blocks are coming from the space in which, say, minimum allocation size is /32. If you try to announce 65,000 /48s, maybe your direct provider will accept that, but some other providers will not. So the real world statistics, these are the numbers from May this year from the route collectors at the RIPE NCC. We have a project called Routing Information Service. We are peering with about 600 peers all over the world, and we think that our view of the internet is quite comprehensive. So when we see that there are around 2,000 entries, 2,000 prefixes in the IPv6 table, that is like the global routing table. So there are about 2,000 prefixes there. There are other people that are doing counting this, yeah?
Well, it looks to me that the red line is going up faster than the blue line now. Why is that?
So the question was, why is the red line, the number of prefixes, growing faster than the blue line number of ASs? I would guess that that is because some AS is announcing more than one prefix.
Do you give them more than one prefix?
Yes, we give them more than one prefix, and especially if they have like the PI customers, then they could announce those customers from the same AS.
Why?
Same routing policy.
You only need one prefix, one AS. That's all you need.
Yes and no, but let's keep this discussion for later. So it is a good question, and it's a good topic for analysis. Why is this happening, and who are these ASs who announce more than one prefix? So the thing is, this is like the usual internet curve of growth. So several years ago, it was 400, now it's 2,000, so it's a huge growth, 5 times. But on the other hand, if you compare this to 300,000 entries in the IPv4 routing table, then IPv6 internet is less than 1% of the size of the IPv4 internet. So why is that? When we say that IPv6 is great, it has more addresses, it has other features like quality of service and the security, and it is great for the multicast, why are so few people using it? Why is not everyone using it? So there are 3 reasons of why are not so many people using IPv6 already, and I'm going to talk about all 3 of them. So first of all, we have the so-called chicken and egg problem, or the dinosaur and the egg problem. Who is going to start first? The service providers are saying, there is no customer demand, so I'm not going to put the money into this. And the application writers are saying, oh, I better polish this code for IPv4 and put some extra features in that rather than port it to IPv6, because who is going to see that anyway? And the end users, well, they don't care, and they cannot ask for IPv6 because they don't know what it is, and they shouldn't care. So as Marco was saying, sometimes they do, and I know that you are this kind of end user that can push the adoption of IPv6. So if you're an Access for All customer, then maybe you'll be getting a t-shirt like this when you go to IPv6. You have to make 500 t-shirts. I got this one. So this can be like a reason why should you ask for IPv6. Also, when you're buying equipment for your home or for your organization or for your business, for your company, try to buy equipment or try to demand from the vendor to make equipment that is capable of also running IPv6. The other thing, what we hear often, is that geeks like us would want to do IPv6, but how to persuade the management? Well, it is a problem. And we, at the NCC, we have a training course, and the material for the training course is available online. So in there are some tips on how to persuade the management. So what I want to ask from you is to go back home and ask from your provider and your vendor and in the office, like, hey, when are we going to start using IPv6? Because this is going to then bring us to the tipping point when there will be actual demand for it. So you can experiment with it, you can play around with it. If you work for an LIR, you should know that it is very easy to get IPv6 addresses from the regional registry. It is for free, or almost for free. It is part of the fee that LIRs are paying to the regional registry anyway. If you are a customer of an ISP, you should push them and tell them it's really easy, try it out. You can get also independent addresses, as I said. So who can you ask? Well, there are already a lot of providers that received IPv6 space from the regional registry. However, not all of them actually have it for their customers. So these are the numbers from the first quarter of this year, and these are only the top 12 countries. So in many other countries, there are smaller numbers of providers that also have IPv6 addresses. We did some other kind of analysis, and we were trying to see how many of these 120 providers in Holland are IPv6 ready. And that is very difficult to determine. What does it mean, IPv6 ready? So we looked into their database entries. So did they create a Route 6 object in the database? Are they visible in RIS, in our routing collector, route information collector? Do they have reverse DNS for that range that they received from us? And are those name servers that they reported to us, are they accessible over IPv6? So based on these four criteria, 1/4 of these 120 LIRs in Holland are 100% IPv6 ready. But only 3 are listed in some of the websites that list what are the IPv6 capable ISPs. So actually many more of them are kind of ready technically, but they don't want to offer it to their customers as a service. So if you decide to actually do IPv6, what is important is to start from the outside. So make your web services visible over IPv6 so that people think, wow, they are ready, but although your network is actually not ready, and let alone your customers. So make your DNS and mail servers and web servers visible over IPv6. You have a question?
Yeah, just a quick question. In the previous slide, you had an aggregate view. Do you also have lists showing exactly who's in the red zone, those who've really implemented? I know it can be politically problematical, but...
No, it's actually a good question, but I didn't explain what this means. These are just the new ones. So these were just the new ones that got it this year. But
you mentioned 1/4 are really IP ready. How do we know? If we go to our providers, they're just going to tell us, yeah, of course, no problem. Not just yet, but sure, we can do it.
Would you like to see that?
Yes.
Because we could show the information, which is actually publicly available. Anyone can look into the RIPE database, into the RIS, and everywhere to collect that information. But it is a little bit tricky. Should we promote these providers? And
yes.
Then, yes?
Yes?
Okay, that's a good one. I hope this video will be available soon so that I can show it to my bosses. Thank you. Okay, so the question was if we want the feedback of the providers that do not provide services and what are their reasons. Yeah, that would be interesting. There is my email address later on at the last slide. And we can also send you the material that you can send to the provider and say, okay, look, it's not that difficult. These are the steps, do this, here's the educational material and so on. So if you can't get native IPv6 from your provider and you still want to test it and you still want to experiment, there are tunneling mechanisms that are supposed to be used for the transition. So these are the tunnel brokers. and yeah, just go there and see what are their conditions. The regional internet registries are trying to educate the general public and our members, and so each one of the regional registries has some project going on, and there is a website where you can learn more. So let's start with Latin America. Oh, this is the LACNIC portal. They have it in Spanish and Portuguese and in English. In Africa, they have the virtual lab, and they also offer a lot of technical courses, and all that material is available online for free. RIPE NCC offers courses only for the LIRs, but still the material is available online, and there is a lot of information. Marco was already giving the URL of this website, so we put a lot of information on there, not only technical, not only for geeks, but also for the decision makers, for the policy makers, for the governments. Aaron's wiki site is more technical, so if you really want to see the examples of the addressing plan and how can you make it in your company, or which equipment actually supports IPv6, this is the place where there is a lot of technical information. And APNIC also has a lot of information on their icons site, so you can learn about this for free. You can learn even more if you like to watch videos or if you like e-learning. So we have e-learning sites. There are videos that we have filmed with the IPv6 enthusiasts, IPv6 advocates, and they all say, it's no magic, just do it. This is how we did it. There is a guy from Google talking about how they did it. Marco will be online soon. So a lot of promotion back and forth. So what else do you have to know? Well, IPv4 and IPv6 are not backwards compatible. So they are going to be running in parallel for many years to come. There will have to be a lot of translation between IPv4 and IPv6 addresses. And the problem with that is that it is the same word, the translation, as in NAT. But in IPv6, we don't need network address translation. We need translation from basically one type of numbering to the other type of numbering. It used to be called NAT-PT, and now it has a different name in ITF. And now there is NAT. So this is what was used to start with in parallel with the development of IPv6 when they envisioned that there will be the shortage of addresses. So they were saying, okay, never mind, we'll just use private addresses and we'll break this end-to-end communication principle. And IPv6 can bring that back again. The problem is, now the NAT became a synonym for the firewall. So as Marco was saying, we will still need firewalls, but we will not need translation. And it is the specifications, the standards are still not ready for the firewalls or for the translations between IPv4 and IPv6. And this is where you come into the picture. So the future of the internet should not be determined with these people who created IPv4 with all these mistakes, IPv6 with all these mistakes. These are the people that need your help. So Internet Engineering Task Force, Internet Research Task Force, ISOC, so many letters. Internet Society, ICANN, RIPE, and North American Network Operators Group. These are all the organizations that are very, very similar to the community of hackers, to the community of free source and open source software. These are all the grassroots movements. Techies who drink too much coffee and eat too many cookies. People who are into gadgets. People who are not afraid of speaking up and sharing their opinion and improving on somebody else's code. So these are the communities that actually need your input. They're all open. So theoretically, the only thing that you need to have is opinion, which I'm sure you have, and an email account. So you have to subscribe to many, many mailing lists, and you have to follow, so you have to have time for that, but it's not an investment of money, it's the investment of your time, and you can make things happen in a different way. So IETF is responsible for RFCs. These are de facto standards. Before they become standards, they are the internet drafts. So when the hardware manufacturer wants to create a modem, they have to read these drafts, and you can be the person actually writing those drafts and telling them, this is what I want to use later on. So these are the areas where maybe you would be interested in. There is a lot of work in the security area, the routing security, DNSSEC. The Internet Research Task Force is busy with some cool protocols that are actually only experimental, and maybe they will never be implemented, but maybe they will. On the last IETF meeting that was held in Stockholm last week, or 2 weeks ago, there were several meetings of so-called birds of feathers. So before there is a working group about something, there is a meeting of people who are interested in a certain topic, and the Codex community is now trying to work together with IETF to standardize Codex. The Virtual Worlds community is creating the open grid to standardize the virtual worlds. So all these new technologies that actually developed outside of IETF now want to get together with this standardization community, and if you're interested in that, you can take part in it. About IPv6, there are working groups that are busy with that, IPv6 operations, tunneling, and the NAT, the classical NAT, and then the NAT between IPv6 and IPv4. Okay, so this was about very technical things. Now, how do you determine how many addresses are you going to receive at home? Or how many addresses is your ISP going to receive in the future? The most interesting policies that are being discussed now are, what are we going to do with the remaining IPv4 space? So this is happening in the RIPE community, and again, the only thing you need is an email account, and you can participate in the mailing list. So this community is also open and transparent. Everything is documented. The documents are published. They're called RIPE documents. They're also kind of standards. The minutes of all the meetings are published, so you can see what was happening before. So this is all made in a very, very friendly and peaceful way, and you have to have quite a tough skin to get into this, because they know each other, they know their lingo, and it will take you some time to actually get used to it. So don't be afraid of being flamed, don't be afraid of being attacked, because what matters is how valuable your opinion is and how valuable your contribution is. Here you can find the working groups. And if you want to come to the RIPE meeting, they are a lot of fun. They don't happen on the camping ground like this, they happen in the conference halls. There was one in Berlin recently, in Dubai, in Amsterdam. There is always a possibility for remote participation. There are webcasts, there are audiocasts, there are Jabber channels in which you can ask your questions and take part remotely, and the next meeting is in Lisbon in October. Nice weather, 1 week of working groups or vacation, whatever way you want to bring it to your boss. So come to the RIPE meeting and help us to create the addressing policies. And again, I'm putting this as a challenge to you. Both RIPE community and IETF community do need fresh blood. We are trying to reach out to other audiences. We now have the YouTube publishing videos. We have the Twitter channel, but still, most of the things are happening on the mailing lists, and a lot of things are happening in the face-to-face meetings. You can tell us, how can we include more people? how can we hear more voices? So you can see in my slides URLs for all these things that I mentioned in the notes. The slides will be published somewhere on the HAR wiki. And if you have any questions or comments, this is my address at Access for All, and it's the same at ripe.net. So this is what I had to say. Go get IPv6. Stay here to hear Marco after 5, and I will take some questions now.
Shall we use up IPv4 space?
Okay, so the question is, shall we hurry up and use up the IPv4 space? We don't have to hurry, it will happen. But actually there was a policy proposal several years ago by a Japanese gentleman saying, let's just stop using IPv4. Let's just tell people there is no more right now, so that everyone will have to start using IPv6 now and not in few years when it runs out. But it wasn't accepted.
If we carry on the way we have been carrying on and keep on using up the IP4 address space, where's it going to bite first? Who is going to feel the pinch first? Will it be the developing world or will it be the developed world? In your opinion?
Yeah, that is asking for the predictions in the future. So what will happen, the policy, there is a global policy now that deals with the IANA giving the blocks of address space to regional registries. When IANA comes to 5 last blocks of /8, they're going to give it to the 5 regional registries. So RIPE will have /8 and Afrinic will have /8.
But that's the very last slice of the cake.
Yes,
Yeah.
and we run through that in, I'm looking at Alex, 3 months, and for Afrinic it will take much longer. So very wild prediction and maybe a good business opportunity is go open your company in Nigeria, and then you can receive the address space from Afrinic and then use it somewhere else in the world. But maybe that's what's going to happen. Other scenarios are that we will not run out of IPv4 addresses, we will just run out of free IPv4 addresses, as in free beer. Right now, you go to the regional registry, you ask for the address space, you get it, you don't have to pay extra. When we don't have any more, you will be able to go and get it somewhere else from people who do have it, but then they will want you to pay for it. So maybe there will be a black market. Other people say there is already a black market. So
Yes, this is a slightly technical question. What was the idea of the auto-configuration protocol for IPv6 being engineered in such a way that all it can provide is basically just an address without any DNS information, without any other options, without even notifying me as the best operator who got this address? What was the idea?
I was not there when they came up with that idea, but maybe someone else wants to explain this. You've been volunteered.
Well, basically, it's the same thing as an Apple token IPX, and they don't have operators because they have no internet in those protocols, and they have no DNS, so they never needed that. So, but if you don't like it, you can use DHCP and IPv6 as well. Of course, your Mac doesn't support it, and probably will never.
Yeah, I was asking several providers for IPv6 support a couple of years ago, and the answer was everything no, there's no request. That's another story. Today, if you have more than, I think, 8 IP addresses, your block has to be an own entry in a RIPE database. Today, or since a couple of years, if you have your own IPv6 addresses, you get a /48 block. And you're also registered directly in a RIPE database. Not?
So the policy about IPv6 registration says that /48 blocks, or any user, well, /48/56, assignments do not have to be registered in the RIPE database. They have to be registered in a database accessible to the RIPE NCC, not to the general public.
Okay, because the question was how is the privacy going on if every private person has its own database entry there?
Yeah, but
The policy is different for the RIPE database for IPv6.
the policy is different. That doesn't mean that it is going to stay that way, but as it is now, that's the policy.
The blocks should be 32 or so, which are registered there.
Only the provider blocks are registered there, or the sub-allocations, that like larger blocks that are given to larger organizations.
And normal companies, they also get a /48 block on, also not included in the RIPE database, in the public URIS database.
Now, that is different. So the provider independent assignments are registered in the RIPE database.
But the PA assignments, not.
PA, provider aggregatable, not. Provider independent, yes.
It's different to now.
Okay.
Fine, thank you.
Hi. There won't be private addressing in IPv6. Is there in IPv6 something to play with? Can I get unregistered addresses?
Unregistered private addresses in IPv6.
As we have in RFC 1918.
So, yeah.
192, 168. Is there such thing in IPv6?
No, there is no such thing as a separate block of addresses. There is a separate type of addresses in IPv6 which can be used for addressing the hosts that is not visible outside of your site.
What is the name for that type of block?
Site local? What is the name? I don't know. So the idea is that IPv6, the devices can have more than one address.
Okay, so there's a whole bunch of different kinds of addresses in IPv6. But these types, they used to be site local, where everybody had the same address block, just like the 10net in IPv4. But then the ITF decided, well, if everybody has the same addresses, that doesn't make sense. You don't know where the packet came from. So then they created something called unique site local addresses. So you do have your own block. You generate it with a random number. So hopefully nobody else uses the same block, but it is private. So you can't use it on the internet.
Thank you.
More questions?
Pronto. Couldn't be someone big, could be frightened by the mass adoption of IPv6. I mean, people behind the IPv4 NAT are bad P2P client, but when someone, many more people have access to a public IP, I mean IPv6, big corporation, media publisher who are now frightened by P2P. I mean, there is maybe a lobby that are slowing down the max adoption of IPv6.
I'm not sure that I understood your question. Can someone repeat the question, or I don't? Can you rephrase it?
Okay, I wonder if behind the slow mass adoption of IPv6, maybe a lobby that are frightened, that many more people than now could be having access to public internet. Now they are behind the NAT, so they are bad P2P clients. Okay, I don't know if I made it better, Claire.
Yeah, I don't know if that is the case. It's a nice conspiracy theory, but I don't think that is the reason for the slow adoption of IPv6. I'm part of them, yes.
No more questions?
If there are no more questions, thank you for your attention. Thanks, Ilic.